All gas furnaces have a high limit switch, which is located on the face of the furnace that extends into the heat exchanger section to make sure the gas furnace does not overheat and cause any problems. The high limit is designed to trip when it reaches a certain temperature and shuts the furnace off so that it doesn't continue to heat and cause a problem. So when a high limit switch trips, you will either see a code 33 for high limit trips or a code 126 for a high heat alert. When these limit switches trip, they will shut the furnace down, and if they continue to trip, they will be a nuisance for the homeowner, and a technician will be called to try to diagnose what's going on. When the technician is diagnosing a situation like this, usually the conclusion is it must be the furnace. But that's not necessarily true. So let's check a few things and see why the furnace is tripping on the high limit. The first thing that we want to check is the incoming gas pressure. This is the pressure being supplied to the home when it comes to the gas furnace. We want to make sure that we have 8 to 10 inches of water column supplied at all times to the gas valve. If you do not have the 8 to 10 inches, you will need to call the gas company to have them adjust the regulator on the meter on the home. The next thing we want to do is check the manifold pressure of the gas pressure being supplied to the manifold itself. You'll need a manometer for this to check the manufacturer's data for the proper manifold gas pressure settings to make sure that the furnace is set up correctly. When setting the manifold gas pressure, you want to make sure that all the other appliances in the home that run on gas are running so that you can check to make sure that the incoming supply does not drop below the 10 inches, and therefore the manifold pressure on the gas furnace drops below a point where it can sustain the flame. We've had cases where the technician will set the gas manifold pressure on a gas furnace according to the manufacturer's specs, and they leave, and then when everybody gets home and starts taking showers and starts cooking and turns on the barbecue or the fireplace, the incoming supply to the gas furnace drops, and so then you have ignition issues. So if you're having ignition issues with a gas furnace and the house is a place where they have a lot of gas appliances, you want to make sure that the incoming supply is sufficient to maintain the proper pressure at each appliance that is running on gas. One of the next checks you want to make when you're checking a high limit switch trip is to take the temperature rise across the furnace. In order to do this, you want to take the temperature of the return air and also the supply air far enough downstream that you don't get the radiant heat off of the heat exchanger. So then we take those two numbers, the supply air temperature, which in this example is 135 degrees, and our return air, which is 70, and we subtract those and come up with a temperature rise of 65 degrees. And so we want to take that number and compare it to the furnace data tag to see if we're in range. So if you've been around a Revco for a short length of time, you should know that we talk a lot about airflow. Airflow is critical when we're talking about things like high limit trips. Proper airflow through the furnace and across the coil and across the high limit switch is very important to the proper operation of the furnace. The ductwork should be checked for smooth airflow with little to no turbulence and no recirculation. On the following slides, we will give you an idea of fittings and configurations that can cause turbulence and recirculation. You should provide as much space between the coil or the bottom of the can the furnace is on to provide smooth airflow out of the furnace. Short cans will produce turbulence and recirculation back into the furnace. If space cannot be provided, a scooped direct air to the left or right should be provided. So this is a common fitting that we see on furnaces out in the field. And like I said, with a short can coming off of the furnace, recirculation is almost guaranteed. When there is not enough room for the air, or there's no direction for the air to take, it will hit the top of the ductwork and recirculate back into the furnace. This type of fitting has a 120-foot equivalent length for this type of fitting on a furnace. By putting some kind of a transition, such as a 45-degree transition, and making some distance between the furnace and the ductwork, you can reduce that equivalent length to 35 feet. By putting turning vanes or a different transition, you can further reduce it to 20 feet. So take a look at your supply connections and make sure that they are the type of connections that will move the air smoothly and freely out of the furnace. So again, this is a typical type of fitting on a furnace where we go out the left and right side of the ductwork. And again, this one will make the air hit the top and recirculate back into the furnace. And you will also have turbulence in this box until the air makes a decision whether it's going to go left or right. And this fitting again is 120-foot equivalent length. By putting turning vanes or some kind of scoop into the ductwork, you can reduce the equivalent length to 20 feet. So once again, you need to make sure that the fittings that you're putting on your gas furnaces get the air out of the furnace in a free manner to provide smooth airflow down the ductwork. And here again, in a downflow configuration with a gas furnace, with a short can, you're going to have the same situation where the air will hit the bottom of the can and recirculate and turbulate back up into the furnace, and you'll have turbulence before it decides to go out the left or the right side of the furnace. And again, you're going to have a 120-foot equivalent length with a fitting like this on a downflow gas furnace. And also, again, by putting turning vanes or a scoop, you can reduce the recirculation and the turbulence and reduce your equivalent length from 120 feet down to 20 feet. Another thing that we have seen on A coils and, of course, other type of coils where you have a flat space where the two coil sections come together, sometimes this flat space is directly under or above the high limit switch. And so the air hits this flat space on the coil and recirculates back up onto the high limit and causes it to trip. So by putting space between the coil and the furnace, that could accomplish resolving the issue. And sometimes we've had to put a A-shaped sheet metal piece on top of the flat part of the coil to direct the air around the coil so that the high limit switch will not trip. So keep this in mind if you have a high limit switch that is tripping on a coil where the flat space of the coils coming together is directly above or under the high limit switch. Another thing you need to keep in mind on most gas furnaces is that there are baffles in the furnace to direct the air around the heat exchanger and onto the high limit switch. One of the things on Carrier and Bryant furnaces is the rear air baffle, which many times when a heat exchanger is replaced, the installer that is doing the replacement does not put this baffle back in place. All baffles need to be in their proper place for the proper airflow through the heat exchanger. The purpose of the rear air baffle is to direct the air from the back of the heat exchanger up towards the front so that we get proper air circulation around the high limit switch so that it does not trip. So this is something you might want to keep in mind if you're working on a furnace where a baffle is missing and it's not directing the air across the high limit switch as it should be. I've stated throughout my videos that I believe that all technicians should have a manometer to measure airflow through a system. Most manometers, and like these digital manometers, are very affordable today, And having a kit like this with the hoses and the pitot tubes and the tees is necessary to make sure that you have proper airflow through a system. So the only way that you can really detect whether you have recirculation or turbulence inside the ductwork is by taking a traverse reading either on the round ductwork or the rectangular ductwork. We have done videos on how to do this, and there's many videos on YouTube that tell you how to take a traverse reading of ductwork. And like I said, this is the only way that you have to prove that you have recirculation or turbulence in a ductwork that is causing your problem.
Go to arefco.com for more videos, like, subscribe, and check back every week for new videos.